Hi guys, welcome back to one another video of MATH FINA. Today we are going to discuss about Pythagoras theorem. It is a well-known theorem in mathematics. Okay, without any delay, let us move to the very important part of this discussion. Here we have the Pythagoras theorem with us. Pythagoras theorem states that the hypotenuse is square is equal to altitude square plus base square. So here one thing we need to understand that everything is based on a right angle triangle here. So the right angle for a right angle triangle, Pythagoras theorem states that a hypotenuse square is equal to altitude square plus base square. So we will be moving to the theoretical part of this theorem here. Okay, here we have one right angle triangle with us. So we have already discussed a right angle triangle is nothing but a triangle with one of its angle is 90 degree. Here we have A, B, C is the sides of this triangle. So exactly the opposite side of this angle 90 degree we have a hypotenuse, and the side which is making 90 degree we have altitude, and B is the base of this right angle triangle ABC. So Pythagoras theorem states that hypotenuse square is equal to altitude square plus base square. Here we have C is the hypotenuse with us, and B is the base of this right angle triangle, and A is the altitude of this right angle triangle. So that we can easily say that C square is equal to A square plus B square. So let us move to the theoretical part of this theorem, how we will be analyzing the logic behind this theorem, how the theorem will formulated, how we will be analyzing the proof of this theorem that we are going to do further. Okay, so here we have our right angle triangle with us ABC, and what we are exactly going to do, we are arranging these right angle triangles so that we will be getting a square. So from that square we will be playing, and we will be arriving at this famous Pythagoras formula, hypotenuse square is equal to altitude square plus base square. So from this picture we can see that we are going to arrange these right angle triangles so that we will get a square. So from this picture we go to one square that we have formulated, we have generated from these right angle triangles. So what is the nature of these formulated square, that we are going to discuss next. So here we can see that one square with us, the square having side a plus b, so area is equal to a plus b square, that is a plus b into a plus b. So one square having side a, then its area should be a square, that is side into side. So apart from these big square, what we are analyzing from the newly formulated square, so we have, apart from this big square, we have one small square with us having side c and area c square. So what exactly we have done here, we have arranged our right angle triangles so that we got a square, and square consisting of one small square and four right angle triangles. Okay, now what we are going to do, we are arranging these right angle triangles so that we will get a same square having same area but different structure of the square that we are going to get from the arrangement of right angle triangles. So what exactly doing, we are moving these right angle triangles that we can see from the picture, that we are moving so that we got two rectangles having side A and B. So the balance part we can see that two squares. So here the turning point of this proof is coming. So we have formulated these square from the previous square, but exactly whatever the area of the square having side C that we have utilized here to generate two squares having a side A and area A square, and a square having side B and area B square, and whatever the area of the right angle triangles that we have utilized to create two rectangles here having side A and B. So this much we have done earlier. So the turning point of the theorem is whatever the area of the square having side C we have utilized to create two new squares having a side A and side B and area A square and B square respectively. So we are having these two squares with us, and from here we will be moving little up so that we will get a space to work on it. But see, we have already discussed that this area, see whatever the area is here with this square having side C that we have utilized to create these two squares having side A and side B. So, and whatever the area of the right angle triangles that we have utilized to create two rectangles having these two areas. So we can see that the area of the square having side C is equal to C square, and the area having the square side B is equal to B square, and the area having the square side A is equal to A square. So what we can conclude here, the area of this square having side C is equal to the area of the sum of the areas of the square having side A and side B. So this is exactly the Pythagoras theorem is telling. The hypotenuse square is equal to altitude square plus base square. So we got three squares. The first square that having one of its side is nothing but hypotenuse of our right angle triangle, and two other squares having sides sides is our altitude and base. So we got this formula C square is equal to A square plus B square, hence proved. So thank you for watching this video. Have a nice day. Bye bye.